marks in the board exam, and also it is a shortcut for your entrance. The question is integral of e raised to ax cos of bx plus c dx. Let us see the solution. Now we have product of two functions, the first being trigonometric in nature, which is cos, and the second e raised to x, which is exponential. So we know that cos is to be taken as u and e raised to ax is to be taken as v. Let's apply the u into v rule. So if I apply the u into v rule, what we'll get is cos of bx plus c integral of e raised to ax dx minus integral d by dx of cos of bx plus c integral of e raised to ax dx the whole dx. Correct? Now let's go to evaluate the integrals and the derivatives. So what we'll get is cos of bx plus c into e raised to ax upon a, because coefficient of x is a, minus derivative of cos is minus of sine, and that of bx plus c, if I differentiate, I get a b. So minus b into sine of bx plus c into e raised to ax by a dx. Correct? Let's write this as e raised to ax by a into cos of bx plus c. Minus of minus is plus, b and a are constants, so can I say plus of b by a integral of sine of bx plus c into e raised to ax dx. Correct, my dear students? Now let's take this step here for our reference. Again we have one integral. Let's go to that. The first part of it will remain as it is. Now b by a we keep it as it is. Again I have to apply u into v rule. Sine will be taken as u. So sine of bx plus c integral of e raised to ax dx minus integral d by dx of sine bx plus c integral of e raised to ax dx the whole dx. Okay, my dear students. So the first part being as it is, b by a as it is, sine of bx plus c into e raised to ax by a minus, now derivative of sine bx plus c is cos bx plus c into b, and integral of e raised to ax is e raised to ax by a dx has to remain. Now let's see the next step, e raised to ax cos bx plus c plus, now can I say b by a square sine of bx plus c into e raised to ax minus of b square by a square integral of e raised to ax cos bx plus c dx. Is that okay, my dear students? Now let's see further. E raised to ax upon a cos of bx plus c is as it is. B by a square e raised to ax sine of bx plus c is as it is. Now minus of b square by a square into integral of e raised to ax cos of bx plus c. Now my dear students, you can understand that particular integral there. Here what we can say is it is nothing but equal to I. So can I say it is equal to I? Correct? Now we have an integral on the right hand side, and because there is no integral sign, I put a plus c1. Minus of b square by a square plus I is on the right hand side, I on the left hand side. So can I say we can combine them to get 1 into or 1 plus b square by a square into I. So if I transfer this term to the left hand side, my left hand side will be simplified as 1 plus b square by a square into I, and on the right hand side we will have e raised to ax by a into cos of bx plus c plus b by a square into sine of bx plus c and a plus c1. Correct? Now my dear students, let's take LCM on the left hand side. We will get a square plus b square upon a square is equal to, let's take a LCM on the right hand side as well. So e raised to ax upon a square, I am taking that e raised to ax upon a square common. We get a cos bx plus c in the bracket plus b sin bx plus c plus c1. Now a square on the left and the right get cancelled out, so we can say that I is equal to e raised to ax upon a square plus b square into brackets a cos bx plus c plus b sin bx plus c plus c, where c is nothing but c1 upon a square plus b square, and this is our final answer. Now my dear students, what we need to do is remember this as a formula. Along with this we require one more formula. So the two integrals which can be asked are e raised to ax cos of bx plus c and e raised to ax sin of bx plus c. Now the formulas are very much similar, so we'll understand them together. The right hand side for both will have e raised to ax upon a square plus b square. Following it, you will have a bracket having two terms a and b. So if you see, both of them start with a, the second term for both of them is b. Now if I take the first case, that is e raised to x cos of bx plus c, after a we will have cos of bx plus c, which is the same as in the question. The first term is cos, therefore the second term will be sine. Likewise, in the second integral, the integral is having sine, so the first term in the bracket will be sine and the second term will be cos. Now between the two, you have to have a addition or a subtraction sign. For cos it is plus and for sine it is minus between the two terms. Now since there is an integral which is evaluated, you should have a constant of integration, which in this case is represented as k. Both these are very important shortcuts which we will be requiring. That's all we have in this module. Thank you very much.